Guys, welcome. Happy Friday, everybody. I'm going to go ahead and mute us for the time being, just for one moment while I get this introduction started. So welcome, everybody. It's 4:02 p.m. We're going to get started on our 2-hour group tutoring session. Remember, everybody, if for any reason anything happens that you can't finish the session, the recording's going to be provided to you. Again, give me until like Monday night to get all that together for you. I'm also going to send the file out with all of the problems that we're going to do today. But man, this is it. We're already here. You know, the group is now, 12, 13 days strong, and it's, again, been blowing up to everything I hope that it could be and more because of you guys. So welcome to Friday's first group tutoring bonus session. We're going to dive right in here. Just a quick little shout out in the chat box. Is anybody here new to these sessions at all? Because I know I had a couple of people sign up that say they were new, but I recognize some names. So in the chat box, let me know if this is your first time. And I'll give it a second, because if it's not everybody's first, or if this is everybody's like second, third time, then I'm going to skip some part of this because obviously you've all heard it before. So I'm going to wait. All right, cool. It doesn't seem like anybody's brand new. All right, so with that said, welcome to your first bonus session, guys. Welcome. So in this session, we're going to be learning mental math, and we're going to be learning mental math for those basic operations: addition, subtraction, multiplication, and division. Now, once we have that down, we're going to go ahead and move into applying it to solving expressions and then solving word problems by using mental math. So there's a 3-phase process here today. I know I said we're only doing mental math, but we're going to get a lot more. I told you guys I'm going to make this session as beautiful as I can in terms of the progress that we're going to make. So we're also going to learn the 3 C's of problem solving. We're going to teach that later on in today's session. Basically, the 3 C's is a discipline structure that you're going to use to solve any problem. Because a lot of us already use the 3 C's to solve regular everyday life problems. We're just going to apply what we know in real life to math. That's it. So we're going to learn that later on. But again, the way that it's going to go is learning the mental math on the operations. Then we're going to dive into solving expressions. Then we're going to go into word problems, just like that. And with the time that we have, hopefully we should be able to get through everything at all, plus some Q&A at the end. But just in case we don't, because obviously we're going to plan for questions and things like that, just know that you're going to get the entire set anyway. So with that said, let's go ahead and look at some updates here. So the first Duran Learning Math Practice Test for ASVAB is going to come out next Friday. So I know a lot of you were super excited about that. We're going to have all 55 questions there in terms of the 30 for the arithmetic reasoning and 25 for the mathematics knowledge. So every single problem is going to have that video solution, because obviously if we're all learning from home, learning alone, online, we're going to need to see what's going on. Like, I'm not going to be that guy to write out the solutions expecting everybody to get the language of math. Adding a little bit of the Italian hand motions and things like that is going to help you out. So with that said, we're going to pick the 2 winners from that upcoming practice test. Remember, like I said, 2 people that have signed up for this session will get that for free. So for a moment, allow me to share my other screen here. And I am going to essentially pick the winner right here. So again, like I said, guys, I wanted to make this as fair as possible. So I went on this website, I put in everybody's name that signed up. You're going to look really briefly and you'll see that your name does show up. Everybody's name is there. I promise you. And what I'm going to do is I'm going to go ahead and just click pick random name. I'm going to do it twice. So the first time, the winner is Janet. Boom. So Janet is, she actually couldn't be here today with us. She is actually taking care of a family matter. And so we're just going to go ahead and, hope that everything's okay with her and her family. But she is one of the winners. I will write that out right here. And then we're going to go ahead and just click it again and see who the other second winner is. And don't worry, even if you are not a winner, don't worry, because I will, if you just message me after this in Messenger and Facebook or whichever way you want to, we can talk about a way where you can still get it for free, because obviously you guys have been here from the very beginning and you're part of this first special practice test, or first special group tutoring session. So I'm still going to find a way to hook you guys up. It just might be a little different than just a simple you won kind of thing. Okay. So the second person that is going to get that practice test is, this is where we go into a commercial break and then we come back after half an hour. All right. So the winner is Jaslyn. Hey, there you go. Boom. So Janet and Jaslyn, the 2 J's. All right. Sounds good. Nice little coincidence there. Perfect. So Jaslyn, you're right there. Congrats. How do you feel about that? Give me a thumbs up or thumbs down. Right on, right on. So I'm going to go ahead and stop showing my screen now. We're going to bring it back all the way over here. I hope you're excited about that. I hope you are. Everybody give her a little congrats, because honestly, it's going to help anybody who takes it immensely. So boom, right back here, back to this little presentation. I see the chat box is blowing up. Congrats. There we go. There we go. So here we go. Let's dive right in. So again, I will send you guys the free access to it with the emails that you guys use to sign up for these sessions when I release it next Friday. So you don't have to worry about taking care of anything. I'm going to import you into the system. You'll be fine. Don't worry. So congrats to y'all. So again, like we said, it looks like everybody in this group session right now has been here before. So I will save my breath and save your time. Boom. You guys know who I am so far. I think I've made an impression in terms of why I do what I do and why it is that I want to make sure you guys succeed. So with that said, we're going to dive right in. Just remember, I'm always here for y'all, always will be, just like I am right now. So let's go ahead and get started. So first things first, guys, we're talking about mental math today. So there's no point in talking about mental math if you're not going to download a mental math app. So with that said, if you have Android, if you have an iPhone, doesn't matter. You can still download a mental math app. So everybody, we're going to take just the next 2 minutes here to allow everybody the chance to download an app. If you have an iPhone, you're going to download this thing called Mental Math Flashcards. This is what the icons look like, so you can easily recognize it. Go ahead, download it. Unfortunately, this app isn't available on Android, but the Magoosh app is. And this is the name of it there, Magoosh Math Practice. It's available on both iPhone and Android. And it's honestly the next best thing. So whichever app you're using, again, either one isn't bad at all. This one's just better because it randomizes it even better for you. It's straightforward. It's not like they have a set of questions. It's just randomized. So if you have an iPhone, you are in a little better luck here, but again, you're not missing out on much as long as you download one of the two apps. And here's the good stuff, Sam, and Chantel, and Ever, and Janelle. So with this app, here's how I'm going to recommend you use it every day. Seriously, the 5 minutes that you take in the morning to look at your phone instead of actually getting up and doing what you need to do some mental math. Anytime that you are literally doing something that you know you're not supposed to be doing, you could probably replace that bad habit with some mental math. I want you to be self-conscious about the time that you use and how you use it. Because the thing is, if you use this app, even for 10 minutes a day, every day, just 10 minutes, literally 10 minutes, every day, I can promise you your speed on the ASVAB math stuff, it's only gonna go faster and faster and faster and faster and faster. Because it's not just about reading word problems, it's about being able to compute because you don't have a calculator. So speed here matters. So again, it sounds like I'm making an advertisement for these companies, even though I have no idea who they are. But I know that these apps work because I've used them myself when I tutor my students. So I don't know the creators of the apps. So I'm not advertising for anybody. They're free apps. Go ahead, download it, make good use of it. And it looks like 5 of us. Boom, sounds good. So with that said, is everybody good for me to move on? Just give me a yes in the chat box really quick. We got 3 of us to download it. Perfect. 4, 5, 6, 7. Sweet, sweet, sweet. All right, that's good. So I'm going to go ahead and move on here to slide number 8. Remember, guys, my number 1 rule, as always, just make sure to try each problem out. By not trying, again, you're forfeiting that opportunity to grow. So just keep that in mind always. Remember the other rules, don't share those answers until the time's up. Even if you think you're right or wrong, try your best because you can't grow if you don't know where you are. And if you finish early, convince yourself that you're good. Always. Redo it, talk about it, whatever you got to do. So, oops, forgot to change that. Today is mental math. Mental math. All right, so that's a quick introduction. All right, just like always, type hashtag Ace The ASVAB if you're ready, and we're going to dive right in. For the next 2 hours, nothing but math. Let's go, let's go. Hashtag Ace The ASVAB, baby. Let's get it. Right on, guys, right on. I'm ready to help you guys succeed. So with that said, let's dive in. Let's dive right in. So we're going to start off with mental math for addition. Now, I want us to go ahead and not use our paper and pencil. That's the idea here. We're not supposed to be using paper and pencil. That's the point of mental math. So with that said, let's just go ahead and zoom in here and just talk about mental math for addition. And I'm going to show you guys how to break this down in many ways. So most of us are used to writing this out. Let's start off with the 54 plus 29. Let's just start right there. A lot of us are used to going like, okay, 54 plus 29. And we're going to add the 4 and the 9 to get 13. We're going to carry the 1. 5 plus 2 is 7. Then add an additional 1, we get 83. Go ahead, give me a yes or no if that's the main way that you would do this. Right, for the most part, yeah, that's exactly how we would do it. Everybody here so far agrees. Now let me expose you to the idea of thinking about it a different way. This idea is called compensation, all right? It's basically like breaking it down into easier steps and then putting it back together. I'm gonna show you exactly how that works. So again, this is called compensation. And the great thing about mental math is that you don't need to take notes. If you want to take notes on the process, sure, go ahead. But the idea is that we learn the process and we practice that process enough to where it becomes memory. That's the idea. So watch this. If I'm adding 54 and 29 in my head, instead of doing it like this, what we're gonna do is say, hey, look, what's 50 plus 20? Really quick, everybody in the chat box, 50 plus 20 is definitely what? Correct, right? It's 70. So I want to change this problem from 54 plus 29 to 70 plus, and then what's 4 plus 9, everybody? Or 9 plus 4? $13, because we can do 9 plus 4 pretty easy. We know that. Maybe not 54 plus 29 immediately, but we know what 50 plus 20 is, and we know what 9 plus 4 is. So I can change the problem in my head to 50 and 20, so 70 plus 13. That makes it a lot easier because I don't have to deal with that unit digit, that pesky unit digit. Don't got to deal with it anymore. And so 70 plus 13, the 3 is automatically going to be there, and 7 plus 1 is 8, 83. It's very, very, very straightforward, everybody. Even if you didn't quite get it the first time, all we need to do is practice. But does that technique make sense? Where we compensate, where we break it down into the digits, so the 10s and the 1s, and then bring it back together to make it easier. Does everybody see that? Yes or no? Perfect, perfect, perfect. Hey, no worries if you never thought of that. Hey, no worries if you never thought of that. Because we're gonna learn a lot more about how to get these things done the right way for sure. So with that said, let's go ahead and dive into here. Now, is a technique like that necessary if the unit digits don't add up to carrying a 1? Not exactly, right? Sometimes it actually isn't necessary. And this is why it's so important to analyze before you actually do it. Because if you analyze, you'll be able to see, okay, nah, this is fine. 23 plus 62, everybody quickly in the chat box, what's that gonna be? Yeah, it's gonna be 85. If we don't have to carry the 1, no need at all. No need, we're fine, right? So notice how these two problems are different. One of them might freak you out because we're like saying, hey, I'm gonna have to go ahead and write this out to carry the 1 and do my thing. And then the other one, hey, that's more comfortable, we know how to do that. Now let me go ahead and go back to the first problem again and show you a different way to do it. So the first way that I did it was, again, break it down into the 10s. Sweet. Here's another way that we can do it. Another way that you can do this problem is by saying, hey, what's 54 plus 30? And if you think about it, 54 plus 30 would be waiting on the chat box there, 54 plus 30. What would 54 plus 30 be? Deja is correct. That would be 84. Yep. Boom. Flooding in now, right? 84. But I went up by a little too much, right? I definitely went up by a little too much. So by how much did I go over? So what I'm going to do is I'm going to compensate for that. So I estimated to 30, but now I'm going to compensate and bring it back down. Since I went over by one number, I'm simply going to come back down one number. So the answer should be now 83. Again, 83. Another technique that you can use by simply saying, hey, look, I just want to work with a 0 in the ones place because it's easier to add. So not 29, I'm just going to go 30. And since that's 1 less than 30, I'm going to come back down by 1. Boom, easy, I'm good. Now I'm showing you a lot of techniques here. It's going to be up to you to pick the one that you like, the one that you're most comfortable with, and really pretty much run with it. It's going to be up to you. So which one do you guys like better? The one where we break it down and put it back together, or where we estimate up or down and then compensate? Which one do you guys like so far? And I'm going to actually let you guys unmute yourselves. That way we can all talk. So there we go. You can unmute yourself to talk if you would like to.
First one.
The first one, Sam? I like that one too a lot because it always works. Always works. With the estimating and then bringing it back or compensating, it really depends on like how close it is to 10, right? You know, if it's an 8 or a 9 or however so. So
I think
either way,
I think number one is more easier because it's like you get to the nitty-gritty, and then number two is like you have to figure out how to, like, if you go over, like, if you did go over by one, you have to reduce it or so. I feel like number one's like more
direct, right?
Yeah.
Exactly. So let's go ahead and go over these next sets of questions here. Let's start with just 29 plus 15. Let's try to do it in our heads, everybody, where we break it down into the 10s and the 1s. So I'm going to count to 5 to let you try to do it. And time. So the idea is that we're going to be able to build up to the point where we can do this in 5, 10, like less than 5 seconds, honestly. We don't want to write things out. We know our brains are faster. So here we go. What are the things that I want to break this down into?
2 and 1, which will be 20 plus 10.
Exactly. So 20 plus 10.
Which is going to give you 30.
That gives me 30. Exactly. And then we're going to add to that.
Which that's going to give you 14.
Exactly. So 30 plus 14 is a lot easier. A lot easier than what 29 plus 15 at a first glance, right? So 30 plus 14, we can deal with that a little easier, and the answer is going to be 44. And that's how we can do it, guys. And another way that you can do it if you wanted to, you can just say, hey, this is 29 plus 10 plus 5. Break it down like that. From 29 to 39, add 5, 44. That's another way you can do it. Just splitting it up in however many ways you want to. The great thing about math, as I always say, is that there's more than one way to do it. So I want to show you these different ways before we get to the crazy part of this session. Because trust me, we're going to speed it up in a bit. But I need to take it slow at first because obviously we need to see these techniques play out. And one last way, again, I'm not trying to overwhelm anybody, but here's one last way. Notice how 29, again, is really close to 30. What would happen if I just borrowed a 1 from 15? So instead of saying 29 plus 15, what if I borrowed a 1 from here to there to make it 30 plus 14? Look at that.
It will be, I'm definitely going to give you the exact same answer.
Exactly. Because you are allowed to say, hey, look, we're just adding 15. What if I just add 1 first and then add the rest, because that's going to give me a nice 30, a nice wholesome 30, as opposed to 29 and I have to carry a 1 or whatever. So basically what I'm trying to show you guys is that all of these techniques, every single one of them, what I'm doing is helping you avoid carrying the 1, because that's the only reason why we write it out like this. Carrying the 1 is the only reason we do that. And so let's go ahead and eliminate that hard part of it by estimating, compensating, breaking it down, whatever way you want to use, it's up to you. But I'm going to challenge you to never pick up a pencil again on most problems, because obviously there are going to be some problems you got to calculate, of course. But let's pick up our pencils and papers as little as possible. We save the most time by doing that. 18 plus 17, I'm going to count to 10 seconds, and I want everybody to type in their answer when they have it. Don't look at the chat box if you don't have an answer. 10, 9, 3, 2, 1, go. All right, so we get 35, 35, 35, 35, 35. Wow, look at that. Pretty straightforward. No, did you pick up your pencil or not? Yes or no? Did you use a pencil or not? There we go. No pencil. That's the idea there, guys. Good stuff. Good stuff. No pencils used. That's my goal for all of us in this session, guys. That's the goal. Now, let's get a little more complicated, though, because obviously they're not going to give you these pretty wrapped up numbers. They're going to give you some decimals every now and then. So let's go ahead and talk about decimals. Here's the thing. Decimals aren't any different at all. They're not. If you want to just go ahead and add 8 and 5 and then worry about the decimals, you're absolutely you're fine to do that. So what I'm saying is, if I have 8 plus 5, what's that going to be, everybody? Quick, chat box, let's go. Perfect. And then I'm going to do the 2 and the 1. What's 2 and 1 together? It makes, obviously, 3. So the answer is 13.3. Simple as that. We're good. I'm not saying that everybody should be as fast as lightning right now. I'm saying that everybody should be able to understand this to be able to do it without using their calculator. And then it's going to be up to you after the session to use that mental math app to get it done faster. That's the idea. So next, go. I'm going to count to 15. 13, 12, 11. Two, 1, 0. Answer. Looks like someone's waiting on the first person to give their confident answer. Let's see. Boom. Sam got it. Chantel got it. 15.2.
Oh.
15.2, exactly. So here's what we got to think about, everybody. No worries, I got your back. Let's go ahead and learn it. So, I'll go ahead, Sam.
You still got to carry the one, I forgot.
Yeah, you still have to do it, but we're doing it mentally now. Yeah, we're doing it mentally. So we can think about it like this. If you want to do the decimal first, it might make your life easier. Because if you do the 0.3 plus 0.9, what's that going to be together?
0.12.
Not 0.12. Think about it like this. If I had 30 cents plus 90 cents, what's that add up to?
Oh.
If I had 30 cents and, yeah, there you go. Exactly. That's $1.20. We literally, once we do the 3 and the 9, we get the 12, but the 1 goes into the next unit place. So into the ones column. And so that would be 1.2 or $1.20. So now I see here that maybe working with decimals may be something we want to focus on as well. Notice how a lot of us were kind of stiffening up there. No problem. No problem at all. I just want you guys to realize it. Hey, if I'm getting nervous working with decimals, then maybe I should work with more decimals. So with that said, what this turns into is 3 and 9 together makes 1.2. Again, the 0.3 and 0.9 together makes 1.2 because you go over to the next unit if you are going above. And then the 6 and the 8, everybody quick. 6 plus 8 is?
14.
Exactly, it's 14. Exactly. So we're going to have 14 plus 1.2. And then together, you're just like adding 1 and 4 together because it's going to be 15.2.
Well, I missed that. Oh, boy.
It's all good. It's all good. Because, again, that's why we're in these sessions to, again, pick apart what we can get better at so that we can do it on our own once we're done. That's the idea. It takes time. So how are we feeling so far about these techniques? Go ahead and let me know. Good, bad, and why. Like if it's good, why? If it's bad, why? Let me know.
The techniques are good because it gives you an opportunity to kind of exercise your brain a little more, to get away from, like you said, without having to use the pencil and paper. So those techniques are fun. It's just you have to take your time and not miss. Simple as like carrying a 1 or not, not doing it right. It can mess you up. So It's just using the steps, using the methods, but they're really good. They really are.
Exactly. Like it's not mindless anymore. It's like you're paying full attention to this. And when you give it more attention, you get it right more. And I'm going to make a point to Jocelyn here. You said it's good, but you need to work on it a bit more. You absolutely do.
Yeah.
Because to be good at mental math, it's not just about knowing the rules. It's about practicing. It's about getting faster. Think about any sport that you could ever play. You could sit down all year long and read that rule book front to back a million different times. But until you get on the practice field, until you practice your butt off, you're not going to get anywhere. So we're learning the rules and we're practicing together, but it's going to take practice and practice and practice to get there. And that's why I said 10 minutes a day is all you need for the ASVAB. I promise you. 10 minutes a day is all you need. If you want to go crazy and go for an hour here and there, even better. Because the more you practice, the better you get. So Jania says, Effie, I get overwhelmed with the numbers and get confused. That's completely fine. Because that's where we're starting then we're going to get better from here. Angelina says, I've never tried to count numbers mentally. I always use paper and my fingers. I see that.
That's true. I always use my fingers.
Yeah, and I know a lot of people that do that. Yeah, I know a lot of people that do that, but the idea is that we got to get away from using paper and pencil for things that we know we can think of mentally. We're going to create that space in our heads to make that work. So with time, trust me, I'll get you there. All right, so one more here is 5.7 plus 6.5. I'm going to give us a little more time here. 20 seconds. Once you're ready, type your answer in, but don't hit enter. Just type it in and get ready. So 20 seconds, go. And try your best to do it mentally. And if you have time, confirm it on paper. And time. Try it out. All right, so Deja says 12, 12.2, 12.2, 11.2, 12.2, 12.2. All right, so it looks like for the majority of us, we got 12.2, and yes, that is correct. Now, I want to approach those of us that may have gotten it incorrect, because again, this is not about getting it right. It's about knowing why we're right. So if we're going about it, I'm saying, hey, if I want to go with the decimals first or the whole numbers first, doesn't matter. Just pick one and go. 5 plus 6, everybody, is?
11.
Correct, 11. And then when we look at the other one, 0.7 plus 0.5, what does that come together to make?
12.
Not 12.
1.2.
Oh, yeah, 1.2.
1.2, not 12, yeah.
Yeah.
So that makes 1.2. And so 11 plus 1.2, what are the only units that are actually interacting with 11 and 1.2? Which place value?
The
11 and the 1.
Yeah.
The ones place, exactly.
The ones
here.
place.
Yeah, the ones place. I think the highlighter's too big. Let me just change it down here. The ones place. Those are both the ones place of both numbers. Because remember, this is like saying 11.0. So what we have is, well, nothing's challenging this 11, the one right here for the 11. So it's 1. 1 plus 1 is 2. 0 plus 2 is 2. Put the decimal place there. And you're good. But the idea is, again, while we're learning this, we're going to take it slow. When we're done with this session, I'm going to challenge you guys. I'm going to email you guys, and we're going to get faster and faster and faster. So have you guys received my email that I sent earlier in the week about the session?
Yeah.
I know about half of y'all opened it. I'm going to start sending out more emails, like pretty much like, every other day, every 3 days kind of thing, just to give you a tip, a reminder of how to best practice and how to move forward. All right. And just to keep you up to date on everything. So 4.6 plus 5.5, I'm going to set a 30-second timer here. I'm going to give even more time here. Take your time, break it down, and check your work. 30 seconds, 3, 2, 1. And once you're ready, type ready. Five more seconds. 3, 2, 1, go. What do we got here? Isn't it beautiful how when we begin together, All of us are like in different places, confused, not confident. And then as we get going in the session, we all come together and get the same answers and start being more confident. That's how it works. That's how teaching works. So, booyah. Right on, right on. Let me go ahead and pin my video. Oops, that's not what I meant. Are you guys still able to see my screen?
Yeah.
Yeah.
All right, sounds good. Let me go ahead and unpin my video. There we go. All right, there, perfect. Sorry, I just made a little mistake here. All right, so let's go ahead. The answer here is again gonna be 10.1 for sure. And I'll review it for everybody here. Here's what we got. So it's gonna be the 4 and the 5 together, which makes a 9. And then when we take a look at the 0.6 and the 0.5, typically 6 and 5 make 11, but because it's 0.6 and 0.5, it's not gonna be 11, it's gonna be 1.1. Because again, 0.6 and 0.5, it would be 11, but there's a decimal place there, so it's only with one decimal place. So you're just gonna put one decimal place back to make it 1.1, which makes it 10.1. So do you feel like you're improving a little bit slowly, yes or no, before we go on to the next one here?
Yes.
Yeah.
Feel like we're improving a little bit? Perfect, sounds good. All right, so I'm gonna go ahead and reveal this first problem here. These first two actually. And I want you guys to do it any way that you know how. And then I'm gonna reveal how to do it on paper and pencil. So I'm gonna give us just about 45 seconds to get that done. I see someone is messaging me that they couldn't get into the room. So let me just copy and paste this link for them. But go ahead, take 45 seconds and get to it. All right, looking at the last 12 seconds here. And time, answers. So what about 64 minus 23? We get 41, okay. And 56 minus 38, what do we get? 28. All right. All right. Sounds good. So with that said, let's review how we did it. So is it safe to assume that with this, we didn't really need to do the 64 minus 23, but if we did anyway, that's fine, because 4 minus 3 gives us 1, and 6 minus 2 gives us 4. So boom, absolutely correct. And there's not really any mental math strategy that would really apply here, other than just don't do this, right? We can just say 64 minus 23, 41, no real hard thinking to do. Now, did anybody try to use a mental math technique that I didn't show you yet here? Or did everybody do the same thing, kind of like writing it out? Talk to me. Use the mic, chat box. How'd you do it?
I used to mental math.
Tried mental math? So what did you do?
Yeah.
Did you try to subtract the 30 first and then the 8?
Yeah.
Yeah, that's exactly how it's going to work. That's exactly how it's going to work. I can seriously do that. I can say, hey, look, all right, I'm going to go ahead and say instead of 56 minus 38, I can say 56 minus 30 and then minus the 8. Perfectly allowed to do that, because if you do 56 minus 30, everybody, what is 56 minus 30? I'm waiting, guys. 56 minus 30, boom. 56 minus 30 is 36. Or whoops, 26. Yeah, so 26. Does it look like 28 is going to be the answer now if we still need to subtract 8?
Oh my god. I was gonna put 18, but everybody's putting 28, so I thought I was wrong, so I didn't put it.
Now I was just playing along with y'all. I was just playing along because I want to show you the misconceptions. I really need to show you those misconceptions. So here, what I did was I subtracted the 30 first, and now I can subtract the 8. So if you want to think about it like this, what is 16 minus 8?
Oh, 8.
Right? If you think about it without looking at the tens digit, you can just pretend that's a 16. And 16 minus 8, that is 8. And so are we going to have to go down one 10 digit? For sure. Because we know that we're going to go lower than 20. And so that would be 1, 8. Now, this is a little more complicated, but let me know in the chat box. Does it seem like it's impossible to grab right now? Do you want to see another example? Or do you feel like you're just ready to start speeding up and practicing? How are we feeling right now about this? Another example?
Another example.
For sure. All right, sounds good. That's exactly. Oh, you guys are hungry. Let's go. All right. So let's go over one together now. Let's do 90 minus 27. So let me just go ahead and show you how I would do this. If I'm looking at this, guys, I'm saying, hey, look, let me do 90 minus 20 first. What's 90 minus 20, everybody?
70.
70?
Yeah, it's going to be 70, exactly. And then we just forgot to subtract that extra 7, so let me just subtract that 7. And so 70 minus 7, what's that going to be, everybody?
63.
Sounds good, Ever? It's going to be 63. Because you can think about it, like, again, like I said, think about it like if it was a 1 there. So what's 10 minus 7? 3, and then just go down 1 unit for the tens.
Oh, okay.
You see what I'm doing there? You see the trick?
Yeah, I see it now.
Yeah, because 70 looks a little intimidating, right? It's a big number. But if I just make it look like a 10, 10 minus 7 is 3, and I know that I'm going to have to go down a digit. I know that for a fact. I'm going to have to go down 1. So from 7
Do
to
you do this for all of them?
It depends. It depends for sure. Because the thing is, sometimes it's not necessary. Like for something like this, once you get fast enough, you'll be doing that. Like your brain's going to do it without you even having to try. Like I'm being real right now. I'm absolutely real. You know how when you do something enough, like tying your shoes, when you do it enough, you don't even think about it? That's the idea here. If you do it enough times, honestly, it's going to be like you're not even thinking about it anymore. You're going to see a problem like this.
I take longer if I do mental math. And so I write it down. Or I feel like I'm missing something. I can't see my mistake. And that's why I feel like I have to write it down. And I'm faster that way because I won't question myself. That makes sense.
And that's the thing about mental math. At first, it's going to be slow. At first, it's going to be slow. But once you have it down, there will be so much confidence behind the thinking that you do that you know you'll be right. And you'll be like, yep, it's 41. Yep, it's 57. Yep, it's 63. But it takes time to build. You have to trust the process. It's kind of like this. Let's say you're trying to go from here to, and let's say we're all in Florida, because I know not a lot of us are in different places. Let's say we're trying to go from Florida to Canada. There's 2 options. You can walk, or you can take time to build a car. Guess what's going to happen? When you walk to Canada, you have to walk there and then walk to the next place and walk to the next place and the next place and the next place and the next place. But if you take the time to build yourself a car or a bike or something, guess what's going to happen? You start slow at first to build it, but once you got it built, bet you're flying all over the place. You're going crazy. You're getting places like 5-6 times faster than that person walking every single time because you put in that work in the beginning. This is exactly what we're doing here. We're kind of building ourselves our own little machine in our heads. That way we don't have to actually pull out the paper and pencil. That's the idea. At first, learning it is a little slower. It is a little tougher. But once you got it down, I'm telling you, just trust the process. You'll be fine. Can we buy into that, everybody? Let's buy into that thing, man. Let's buy into it because let's try this one out. How are we thinking about a problem like this? So don't do it. But how are we thinking about it in terms of what operations you're doing?
I kind of did like 12 minus 6 and instead of 120.
Exactly. I'm saying, hey, look, I'm going to take anything but the unit digit. So it's 12 minus 6 right now. Technically, 120 minus 60, but you can just think about it like 12 minus 6. What's 12 minus 6, everybody?
Or 6.
That's 6. And it's the tens digit, so you got to put a 0 back in there. Because it's not 12, it's 120 technically. So just put the 0 back in. And now that you did that,
it makes it like 60, basically.
Exactly. It makes it 60. And now you still have that 0 minus 3. So, or the 0 is already here right there. So It's just 60 minus 3.
57.
And what's 60 minus 3? I think that's a lot easier, right?
Mm-hmm.
Yeah.
And what did that end up being, everybody? Someone just typed something, but it wouldn't let me type
57.
it in. Yeah, it'll be 57. Exactly. And if you want to confirm, for sure, write it out to confirm it and use that as a confirmer, as a verifier, so you can build your confidence. So you can say, hey, 120 minus 63, if we really want to feel it out. All right, I'm going to borrow 1. And then I got 7. And then I got 11 minus 6. And that's 5. Boom, done. But the thing is, before you even wrote out the numbers, the 120 minus 63, if you trust the process with mental math, I will bet you how much I earn in a month, that you can get this done before someone else can even write down the numbers to even start doing it. That's how fast you can get. And you think it's impossible right now. And I understand that if you've never believed in yourself in math, but I'm here to tell you that you can do it. It just takes time and perseverance, just like anything that's worth it in life. Seriously. So with that said, let's move up into some decimals here. Let's get it. So 9.6 minus 3.5. Is this one tough? Yes or no?
Yep.
Yeah.
It's not really tough, right? Because we don't have to borrow any ones or anything. So just do it straight up. Everybody, what's your answer? And again, be confident. Be confident. Whatever comes up in your head, type it out. Yeah, don't wait for people to type in their answers. That is not how these sessions are going to work, guys. You gotta type out your answer and be confident. And if you're wrong, just say, hey, why was I wrong? Just say why.
Is this 6.1?
It is, because the 9 minus the 3 is the 6.
Mm-hmm.
Your decimal place. 6 minus 5 is 1. Done. Again, that one wasn't particularly tough. Not at all. Not at all. But let's talk about this one. Let's talk about it. 9.3 minus 6.8. What should we do first?
9 subtract 6.
Absolutely. 9 subtract 6 in my head is 3. And then it's like saying 0.3 minus 0.8. Ooh, that's a little weird, right? So here's one way you can think about it. How far do you go, not from 0.3 minus 0.8, but how far do you go from 8 up to 13? Yeah, say it, type it out. I want to hear it. I want to hear it. I want to hear it.
Is it 4?
No,
5.
It'll be 5.
Oh, 5. I was like, wait, I'm missing one.
No worries. It'll be 5. And so the thing is, it won't be 3.5 because, again, we're subtracting. So that's going to be gone. It's actually going to be 2.5. So here's the process in my head again. I'm going to really highlight this with my little tool here. I'm saying I got 9 minus 6. That's going to be 3. But since it's 0.3 minus 0.8, I know I'm going to have to go down again. So instead of it being 3, it's going to be 2. And I know 13 minus 8 is 5, so 2.5.
Oh. Yeah, I got a little lost there.
No worries. Because again, it's just going to take practice. The more you see it, the more recognizable it'll be.
It's like easy the way you showed it, but in my head I was like, ugh. And then
I was lost.
Yeah.
Same.
Hey, no worries. I'll go through it one more time here before we continue. Just I really want you guys to see this, because there's another way that you could do it to make your life easier, especially when it comes to decimals. You can just go ahead and start off by saying 9.3 minus 0.8. Just do that at first. Because in your head, you can think about it like 93 minus 8. What's 93 minus 8, everybody? In your head, if you did 93 minus 8, what would that be?
85.
85, correct.
Yeah, 85.
Yeah, and if you're trying to think of a mental math way to think about that instead of writing it out, you can say, hey, there's a 3 there, and if I took away the 3 from the 8, what would I be left with?
5.
That's 5. 93 minus 8 is the same as saying 90 minus 5. That's a little easier, because 90 minus 5 is 85. So I can say that this is 8.5 minus 6, because again, I only subtracted this first. So then what's left? Just the 6. 8.5 minus 6. That's a lot easier. That becomes what, everybody?
2.5.
Exactly. It gives you that little 2.5 at the end there. Booyah. So I'm overwhelming you guys with some mental math. I know. It's not easy. It's not going to be easy, but that's why we're doing it. So I'm going to present this next one to you, and I'm going to time us. I'm going to give us 20 seconds to do it in our heads and maybe do it again and maybe do it a third time. Let's see how many times you can confirm your answer. Here we go. 20 seconds in 3, 2, 1, go. Again, do it in your head and confirm it. If you want to start with the decimal first, go ahead. 4, 3, 2, 1. Let's see if we got it down. What's our answer?
1.7.
I messed that up. I'll put 1.3.
Let's see. Let's see you got 1.3, 1.7. What do we got? What's it going to be?
It's probably because you went with 0.4 minus 0.1 and not 0.1 minus 0.4.
Yeah, that can happen. That sounds like that's what happened too. Yeah, Janine, you got it right. It's 1.7.
Oh.
Yeah, because here's the way we can do it. There's a few different ways, honestly, guys. Quite a few different ways we can do it. I can seriously say, hey, 8.1 minus 0.4 first, because that's the same thing as thinking of like 81 minus 4. If we move those decimals away, 81 minus 4, everybody, would give us 7.7 or 77, but then turn it back into 7.7 in your head. And then all that's left to do is 7.7 minus 6, 1.7. Again, we want to do our best to do it mentally. But before I continue with this, everybody, before we go to the next slide to talk about multiplication and division, let me ask you this. If I were to give you a worksheet that had all of the basic single-digit operations, so your times tables from 1 to 12, your division, adding numbers that are just single digits like 8 plus 7, 6 plus 5, subtraction. If I were to give you something like that, would you be able to do it rapid fire? Like the 8 plus 7s, the 8 plus 2s, things like that. Is that something that you can do fast? Because if not, then when the mental math app, when you open that up and start with single digits and go as fast as you can and just go. Because notice how a lot of this depends on your ability to know these basic sets of information in, like knowing how to borrow a 1, like adding an 8 plus 7, or adding single digits, multiplying single digits. It's gonna depend on this. So what I'm saying is, in that mental math app, start off slow with the single digits, blast that as best you can, and then double back and then do the 2-digit numbers. Then do a little more than that to try to get it in your head. Because the more that you can do in your head, again, the better it's gonna be for you on test day. The less you have to write down and actually physically transition into writing, the better. So last one here, 4.5 minus 6.7. This is a challenge one because the answer may not be positive. So I'll give us 30 seconds here. If you want to try it out in your head or actually write it on paper, see which way works best for you. 30 seconds. 3, 2, 1, go. Two, 1, and 0. 4.5 minus 6.7. What do we got, everybody? So we got a negative 2.2, a negative 9.8, a positive 2.2, a negative 3.8, positive 2.2, positive 3.8. So we're all over the place in this one. And it was a challenge question. So this is what I'm going to show you in terms of analyzing before you do. If I'm checking out the problem, guys, I'm looking at this, and if I'm taking 4.5 and subtracting 6 point anything, is the answer going to be positive or negative?
Negative.
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 Correct. The answer will be negative. Now, because of that, what we're going to have to do to combat that is, well, you can just flip it. You can just say 6.7 minus 4.5. But just know that the answer has to be negative because we flipped it to see it better. But just know that the answer is going to be negative. And you want to know why this works? And it's because subtraction is taking the difference. You're just saying, hey, how far away are these numbers from each other? And it depends on which way you subtract them. If it's like this, it's going to be negative. Like this, it's going to be positive, but it's going to be the same number. Because 6.7 minus 4.5 is a positive 2.2. But we have to flip it back because it was the small minus the big, not the big minus the small. So that's going to be negative 2.2. Who didn't know that you could do that? Again,
I didn't know that.
If it's a small minus a big, you can just flip it and just be like, all right, I'll do the big minus the small to save my life. And then just remember to make it negative at the end. So give me a yes or no in the chat box or with your mic. How do you feel about something like that? Taking something that was seemingly complicated.
It was easier when you flip it, so that way you can actually see what you're doing, and then that you just always remember put negative, since the original question it was 4.5 minus 6.7 set up the other way, basically.
Yeah. And we just have to understand that difference means, hey, how far away are they from each other? And it just depends on how you're subtracting them for the negative or positive. That's it. Difference means how far away are they? So with that said, that is the second round there, the second warm-up for subtraction. We're going to dive into multiplication, then division, work on expressions, and then dive into those word problems. So let's look at multiplication. I'm going to walk us through here. If we're trying to do 22 times 3, do we need to write anything out here or apply any special technique?
No, not
Nope.
really.
What's the answer, everybody? 66. Right on, everybody. Good stuff. And so what we're dealing with, again, you can treat it, say, 2 times 3, 60, 2 times 3, 6, all done. You can do it that way, and you're good. And you're absolutely good. I want to show you this other way, too, because this can work when it comes to bigger numbers or more those weird numbers. I can split this up into 20 times 3 plus 2 times 3. Here's why this works, everybody. Well, let me just go ahead and show you what's going to happen here. 20 times 3, 60. 2 times 3, 6. Bring them together, you make 66. That's what happened in my head. The reason that this works is because the distributive property. You guys remember that from the binomial stuff? Distributive property. If I have a 3 times 22 in a parentheses, remember that you can switch that to 3 times, well, 22 is 20 and 2, so 20 plus 2. What I did was I broke it down into the unit digits. I broke it down to the 10s and the 1s. Because if I distribute, that's what happens. 20 times 3 and 2 times 3. And then I can just add them together at the end. Sam, yes, I know. Go ahead and just do me a favor. Pause yourself right now. Go grab your mop. I know your brains are all over the floor. Just go ahead and grab it. Clean yourself up, and you're good, and we're going to continue. That's what I'm here to do, guys. I'm here to blow your mind, though. But yes, you can apply the distributive property and everything you know into everyday math. You absolutely can. I'm sorry your teachers never really told you that. I'm sorry. But we're here now, and we know now. So, so with that said, let's go ahead and apply that same technique to 15 times 4. Because what I can do is I can break it down in my head. Again, what I'm about to write is in my head. I can break it down to 10 times 4 and 5 times 4. And then bring it back together. 10 times 4, 40. 5 times 4, 20. Bring them together, you get 60. Who wanted to grab their paper and pencil for this one? But now
I do.
don't.
Me.
You wanted to, right? You really wanted to.
Yes. Yes.
But do you see that you don't have to?
Yeah.
I kind of did it like 15 times 2 and then just added, it did it again and just added it.
Ooh, Chantel, thank you for pointing that out. Thank you, because I almost forgot about that too. Again, there's more than one way to do math. Here's method number 2. Remember how I said in the last session that 4 is the same thing as saying 2 times 2?
Mm-hmm.
Yeah. So if I'm gonna multiply by 4, hey, I'm not gonna multiply by 4. That's a big number. Let me just multiply by 2 and then multiply by 2 again. So 15 times 2 times 2. Because 15 times 2 is 30 and 30 times 2 is 60. That's just another way to do it. You can break it down by the factors. So if you're multiplying by 6, you can multiply by 3, then by 2. If you're multiplying by 10, you can multiply by 5, then 2. But obviously, if you're multiplying by 10, you can just move the 0. Like, you're good. But you get the idea. You can break it down into easier steps. That's what mental math is all about. Like, literally, me knowing mental math does not mean that I can do, like, 57 plus 87 in my head like that. No. It means that I know how to break it down to make it easier for myself to do, so that I can still get the right answer by just taking a little shortcut. That's what mental math is, taking mental shortcuts. That's what it's all about. So with that said, let's go ahead and look at this next one here. I want you to apply that technique. Try the 10s out, then try the 1s out, or multiply by 3, then by 2, whatever you want to do. Try it out. I'm going to give us 45 seconds here. Use the
Them gone one.
and then go. All right, 3, 2, 1. What do we get for that first one? Again, guys, be brave, be brave. What do we get?
144.
144. Now, who here used mental math and got it right?
Me.
Is that Delila?
Octavia.
Oh, here, Octavia. Oh, I'm glad you could get in. I'm glad you got the link. For sure. All right, cool, cool. We got 144. Let's break it down, guys. Let's see it. Let's see it work in action. So you can either do 24 times 6, take all the time in the world and be like 4 times 6 is 24. I'm gonna write the 2 up there. Oh my God, I'm bored. 2 times 6 is 12. Add the 2. I could have done my taxes by the time I did this by hand. Look at that. 144, right? Wow, I could have literally walked my dog and finished my day. But let me go ahead and use mental math because I hate wasting time. All right, bet. I'm gonna go ahead and break this down in my head to 20 times 6 and 4 times 6. Because then I'm gonna bring it back together by saying it's 120 and 24. Add them back. We Gucci. 144. So, are you guys buying into the mental math program now? You guys are just getting started and you guys are seeing what it can do. I'm telling you, once you start practicing this, there's no turning back. I'm gonna bet that half of you here within the next 2 or 3 days are gonna be looking at math problems and be like, man, I don't need to use my pencil for this. And you're gonna be annoyed when you do have to use a pencil. It's like, I shouldn't have to. And you're gonna try. I bet you half of the people here are gonna do that. So let's take this 16 times 5 here. 16 times 5. In our heads, let's see who can get it first. Virginia, that was fast. That was fast. Yeah, 80. And for everybody though, let me break it down for us. I'm gonna show you 2 ways to do this because I'm gonna show you how to manipulate 5s. There's a secret to multiplying by 5 that you can use that's pretty easy to do. So watch this. Here's the main way though. The main way is, let's break it down to 10 times 5 and 6 times 5. And that's gonna give us that 50. And that's gonna give us that 30. Do you guys see how important it is though to know your regular digit by digit multiplications? It's very important to know that very quickly because if you don't know it quickly, then mental math is gonna be a little rougher. So that's why it's important to start with those unit numbers and then move up. Those single digit numbers and then move up. But here we are, that's 80, we're correct. Now let me show you guys how to multiply by 5 in an even faster way. Everybody, if I had to multiply by any number besides 1, what's the easiest number to multiply by? 2, 3, 4, 5, 6, 7, 8, 9, or 10? Which one of those numbers is easiest to multiply by?
10.
10.
Right? 10, automatically. We know that it's 10
Yeah.
because when we multiply by 10, we're saying, just put a 0 at the end. We're done, right? That's what we're saying. But if I want to turn a 10 into a 5, what do I have to divide by?
2.
2?
Yeah. If I have a 10 to get down to
Oh,
5,
2.
I gotta divide by 2. So think about it like this, and I'm gonna blow someone's mind right now, so pay attention. 16, instead of multiplying by 5, let me go ahead and multiply by 10 and divide by 2. Because human right here,
What?
10 divided by
What?
2, yes or no?
Oh
That's
my
5,
god. I think my brain just exploded right now.
right? 10 divided by 2 is 5, right?
Right.
Right, so this is the
Right.
same thing. These are the same thing right now. I am not trying to confuse anybody. All I did, don't worry about everything else. I just changed the 5 to 10 divided by 2. Because here's the thing. When it comes to a fraction, you can simplify first and divide, or you can multiply first and then divide. Either way works. Either way, it doesn't matter. And let me prove it to you. Let me go by dividing by 2 first. Everybody, what's 16 divided by 2?
8.
8. So what's 8 times 10 in your head?
80.
Hmm.
I like that way.
Yeah.
I like that way better because you go,
Okay. Let me look at it the other way
oh,
then.
you simplify.
What if I multiply by 10 first, then divide it by 2? Everybody, what's 16 times 10?
160.
160. And what's 160 divided by 2?
80.
Oh, look at that.
Freaking crazy.
This is crazy. This is
It
absolutely
is
bananas.
crazy. Oh my god. I was like, wait, isn't that like supposed to be, if you times the 16 by 10, it will be 160?
Yep.
I was like, oh
Why
my
am I
god.
24 and just learning this?
Hmm?
Why am I 24 and just learning this?
Yeah,
That
me
wasn't your
too.
teacher.
I'm learning this too. Because like I was like itching with like, where's my paper at? And so, like, oh my god.
But that's the idea, guys. Like, I want to show you guys that you guys are a lot more powerful than you think. The only thing that's different is that you may not have had the right coaching growing up. In school,
Yeah.
a lot of what they teach you is literally like, I'm going to show you this one way to do it, and you're going to do it that one way for your entire life. But that's not how math works, and I'm sorry that you guys didn't get to learn math the right way. Again, math is a language. You cannot learn a language by only speaking it in one simple way. It takes versatility. You got to explore it. And this is what math actually is. When it's supposed to be fun. Like this, it's supposed to be doable and fun. Not, Sam's like, school sucks. I'm not going to say that because I was a teacher, but yeah. But the reason I left teaching was simply because I saw that they were only teaching it one way and they were doing very wrong by the kids. Very easy to see that. And so I started my own thing. But here we are. 6 times 1.2. Let's work through this together because with decimals, it looks more complicated, but I guarantee you it is not. Everybody, what happens when you go and do 1.2 times 6? At the end, whatever number you get, what do you do about that decimal place?
Move it.
You bring it right back, Artavia, right? We bring it right back.
Right.
So whatever number you get, 1.2 times 6, that should give us 72. And then that decimal place, you bring it right back. So 7.2 is the answer. But that's, again, if we did it that way. Look at how much real estate we just used. We don't need to use any real estate. We got a lot in here. We got a lot in here. So this is how we're going to break it down. I'm going to go ahead and say, what's 6 times 1? 6. And what's 6 times 0.2?
12. Oh, I mean 1.2
Oh, but what do you do with that decimal place?
in the middle, so it'll be 1.2.
Booyah. There you go, Jaslyn. Yes. 6 times 1.2 is 12 with a decimal, so 1.2. What's 6 plus
Oh, that's easy. Now you just add the one place, so it's like 6 plus 1 will give you 7. So and you bring the 2 down, so it'll give you 7.2.
Exactly. Guys, I'm going to let you know something about me right now. You ever heard that phrase in school, work smarter, not harder? You ever heard that?
Someone not really.
Work harder, not smarter.
No, work smarter, not harder. So
Oh,
do things
okay,
the
work
smarter
smarter.
way, not the harder way, right? Yeah, that is perfect for lazy people like me. I love mental math because you're doing math in the laziest way possible, knowing that you're still going to be right by only doing it the easy way. I'm not going to sit down here and write this all out like this in purple. No. That's the boring way. That's like saying, hey, count to 100, or what's 50 plus 50? And then you go out and you pull up a bunch of like cardboard sticks and you lay out 50 here, you lay out 50 there, and then you start counting together. Everybody together, here we go, Blue's Clues. 1, 2, no.
Do you like have one of those teachers get so frustrated when you do that way? They were like, well, you don't show me examples like how you get that answer, like you write it down on the paper.
For sure, but then once you teach mental math, you can move beyond these techniques and move into the more complicated stuff and actually feel confident about talking about it. That's the idea. So next, 5 times 1.8, I'm going to allow y'all to do this on your own. 45 seconds, go.
Okay.
Don't share the answer. Don't share the answer. I like these 2-hour sessions. It gives me enough time to get that true warm-up in and then the actual stuff coming up. I like this. Check your work if you're done.
Yeah.
Check your work if you're done. 3, 2, 1. Let's get it. If you're right or wrong, I don't care. What's the answer?
Is it 9.0?
6.8.
9.0.
Yeah, I got the answer. 9.0.
We got 9.0. Someone got 6.3, 6.0, 9.0. Let's see what else we got, because I know there's more than 5 people here. Come on, share your answers, guys.
3.8.
Participation is mandatory in my room for sure. You guys paid to be here, so I'm gonna make sure that you participate. I'm gonna make sure that you get everything that you paid for today and more. Nah, Deej, you didn't do it wrong. You did it right. Because 180 divided by 2 is 90, not 6. So you just messed up on this writing the 6 as the 9. That's it. You should have wrote the 9. That's it. That's all, Deej. You got it right. So
I know I would have got that wrong in the test, because I would have just looked at the 5 times 1, the 6. I would be like 6 something or 7 something. I wouldn't have thought it was 9.
Yeah. You know, the thing about guessing is that there's never any confidence behind it.
Mm-hmm.
And that's why I hate guessing. I like to know that I'm right before I even say anything. One thing I want y'all to know about me is, like, when it comes to like arguing with people, I don't argue unless I know I have a point to make. Like, that's just what I do. And that's the same thing kind of here. Like, you don't want to guess, you want to feel confident. So analyze first and then attack. So you can do it the first way, right? You can say, hey, 5 times 1 and 5 times 0.8. 5 times 1 is 5. Everybody, what's this going to be? We're frozen, right? Okay, let's make it easy. What is 5 times 8?
That'll be 40.
40.
40. But what did we ignore when we did that?
Oh, you have to put the decimal in the middle, so it'll be 4.0.
Exactly. So we said that 5 times 8 is 40, but because we moved that decimal, just make it 4.0. That's it. And 5 plus 4.0 gives us 9.
9.
Say 9.0, but 9 is the simplest way to write it. So Alexis, do you see that there? I want to make sure that we're all good.
Okay.
Yeah, Alexis, I do not want you to be lost. And we got plenty more examples to go through. Okay, Angelina.
Artavia lost too, though.
What was that, Alexis?
Artavia is lost.
Oh, got you. My bad. Because I'm trying to see where the mics pop up. It like, hey, I got to track it a little better. But there we go. Another way that we could do it, multiplying by 5 technique, right? We can say, hey, instead of doing 5 times 1.8, we could do 10 over 2 times 1.8. And you can go either way. You could divide or multiply first. It don't matter. So I could say, what's 10 times 1.8? That's going to be 18. That's going to be 18. Because I just remember, when you multiply by 10, just
Oh, okay.
And then when you divide by 2, what's going to happen?
Oh, it's gonna give you the 9.
Look at that. Look at that. Ain't it funny how math works sometimes? It can work for you, not against you sometimes. How are we feeling right now in the chat box? Let me know. How are we feeling so far?
I'm alright. I'm okay. A little better.
That's good. Again, I want the direction to be in the good direction. I'm not expecting y'all to leave this session like ready to, or no, I don't want y'all to leave this session believing that you should be able to conquer the mountain that day, same day. No, the idea is to give you the tools that you need to get better. I'd say that all day, every day. That's what the goal is, to give you the tools you need to get better. Let's do 8 times 2.4, and we're going to move on to the next section here. I'm going to, again, give you guys all of these files, but let's go ahead and do the 8 times 2.4. Try to do that in your head.
Yeah.
So don't share the answer. I'm just going to count for 25 seconds here. Smarter than yesterday. Ten more seconds. Time. What do we got?
1942.
And look at that. The first 2 people to answer are on the same page, but looks like a lot of people are timid. A lot of people don't want to share their answers, guys. I'm not here for that. Come on. Be confident here. It's okay to be wrong here. Stop waiting for people to write their answers before you write your answers. I'm calling all of y'all out right now. When I say go, man, you got to type that answer out and go, because that's how we're going to learn if we're right or wrong. And you got to let go of that pride, because that pride is what's stopping us from growing right now. You got to let go of that pride. So 8 times 2 gives us 16.
Mm-hmm.
Cool. We know that. That's something that we can all get around. But now it's the complicated part, the 8 times the 0.4 part. If I don't want to think about 0.4, what can I think of instead?
8 times 4.
I can think of 8 times 4, but always remember to do what at the end? Type it out in the chat box. Everybody, what should we have to do after the fact? Again, if I change it to 8 times 4, I have to remember to do what at the end? Bring back the
decimal.
Decimal. Replace it with a decimal.
Exactly.
So it will be 3.2.
Exactly. And that's going to give us that 19.2. Because notice the addition at the end is so easy. It's just the 6 and the 3 that's coming together. That 1 there and that 2 at the end, they don't matter right now. It's just this that's interacting. So in your head, this should be like paradise. Because again, you're just breaking it down and making it as easy as possible for you. But I hope you guys are seeing that you have to apply those little rules. The decimal, bring it back. Oh, I got to know how to multiply 8 and 4 quickly. Things like that. So I said we're going to skip that last one so that we can get it, so we can get division real quick. I'm going to skip the decimal parts of division because as long as you learn this, you shouldn't really, you can apply the same technique to division. So let's start here real quick. 76 divided by 4. Let me show you this division technique, and I'm going to let y'all run with this. 76 divided by 4, everybody. Who knows that off the top of their head? Nobody. Exactly.
No. Cool.
So,
I suck at this. Oh, God.
We're going to break this down. Like I said, guys, work smarter, not harder. Don't put your pencil on paper right now. Here's how I'm going to do this. Everybody, what's 4 times 10?
40.
Correct. 4 times 10 is 40. If I make 76, 40, and something else, what's the remainder? What's left over? 40 plus what makes 76?
36.
Yes, 36. 76 is the same as 40 plus 36. Why is that important? Why did I just do that? All I did was I broke it down into 2 easier divisions. I looked at this and I said, yo, I want to vomit. I'm not trying to do a big division right now. Not my goal right now. Instead, though, I know that 76, 4 times 10, that's pretty easy. 40, what's left over? 36. Everybody, quick little question. What's 40 divided by 4 again? We just said it. What's 40 divided by 4 again?
10.
10.
Absolutely, it's 10. We just said that. That's why we put that number there, because it's a multiple of 10. It makes my life easy. And what's 36 divided by 4?
8. 9.
Not 8. 9. It's 9.
Yeah.
Everybody, what's 10 plus 9?
19.
Break it down. Break it down. And notice, some of us were a little hesitant on these, on dividing by 4 with those. And again, that means in the Mental Math app, you need to go and do rapid fire division, 2 digits by 1 digit, doing like 45 divided by 5, 56 divided by 8, those kind of things. You can be quick at those so that you can be quicker at Mental Math. You see how that's related. That's why I had you download that app. That's why it's related. You got to promise me and promise yourself that you're going to be doing it and just keeping up with it. You have to. Now, I'm going to teach you another very easy way to do this. Everybody, 76, it's really, like, something I noticed is that it's really, really, really close to 80. If I had 80 and I divided 80 by 4, would that be an easy one to do?
Yeah.
Yeah.
What's 80 divided by 4? Yeah. Dania says 20. I agree with
20, yeah.
Dania and Cordy. Yes, it's 20. 80 divided by 4 is 20. If you didn't know that, again, just take a note that Mental Math is going to be your thing later on. But here's what division means. It means how many groups of 4 can fit into 80. 20 groups of 4 can fit into 80. But we're not trying to see how many groups of 4 can fit into 80. We're trying to see how many can fit into 76. Guys, quick question. Pay attention here. How many 4s do I need to add from 76 to 80? How many 4s did I put in? An extra 4, right? With 76 plus 4 would get you to 80. So I added an additional 4 that I didn't need to. Remember, this tells me that this is 20 groups of 4. If I take away one of those 4s, it's 19 groups of 4. That's another way to think about it. Again, you don't have to master this today. We just have to be exposed to the idea. Jania's over here like having a seizure. This is awesome. So, yes. Yes. So which way do you guys like better so far? Breaking it down into 2 easier divisions, or seeing what the nearest number that you know is and then adding or subtracting however you like?
I feel like the first one is easier than the second one. Second one got me lost.
Yeah, I was lost on the second one.
And that typically happens. And that's why I always teach in 2 ways. Notice in the classroom, they only teach you one way, and then they move on to the next chapter. What teachers need to do is they need to teach it multiple ways so that we can let you, the learner, pick which way you like best, giving you options. Think about it. When you have options versus when you don't, you tend to like it when you have options. Not when you go to the wherever and they're saying one way or the highway. If you have options, you can do a little better. Now, let's apply that here with 84 divided by 6. Is there a nearby number here? Not obviously. I don't see an obvious nearby number like 60 or 120 or 180 that I can really throw this into. So what I'm going to do is I'm going to break 84 down. What 2 numbers should I break 84 down into? The first one is always the multiple of 10.
42.
8.
Ooh, I heard someone say 42 and 42. Why did you pick those 2 numbers?
Because 6, first it divides perfectly, and then the 6 goes into the 42.
Exactly, because 6 divided by, or 42 divided by 6 is what?
7.
Exactly. When we divide at the end here, you get 7 and 7. And 7 and 7 makes
14.
It makes 14. Now, that may look a little complicated, but it's not really that complicated. Let me break it down for you a different way. Allow me to just take this And just move it over right here for one moment, because watch this. I'm going to blow your minds now, guys. 84. This is the technique with breaking it down. I'm going to use familiar numbers. Remember earlier how I said, 76. I know that that's more than 40 because I know 4 can go into 40. So I broke it down into 40 and 36. Now look back over here. 84. Is that more than 60? Yeah. By how much?
24.
Yeah. That's 60 and 24, guys.
Dang, that's crazy.
And what and what's 60 divided by 6? Since I'm dividing by 6 now, what's 60 divided by 6?
10
That's 10 and what?
and 4.
What's 10 plus 4, everybody?
14.
You got people laughing now. Is someone here having fun with math? Finally?
I'm getting there, but I'm still getting lost.
It's all good, Jaslyn. It is all good. That's why you get the recording, and you're going to get the pause and rewind it as many times as you need to. I'm giving you every opportunity to succeed here. I got you. Why can't I think like Vinia, you can. You just have to give yourself the time and patience. Because to get to this point, we may need to work on our mental math game a little more with the smaller numbers so that this becomes a little easier and better to understand. Because Jania, I'm willing to bet that you understand the idea that, hey, yeah, all I'm doing is breaking it down into different numbers. But it may be confusing in terms of the speed, in terms of doing this in your head quickly. And if that's the case, all that means is just you need to practice a little more with the smaller things to build back up into this. Yeah, that's all that means. So be patient with yourself. Seriously, I got your back all the way through. Just be patient. So guys, I'm making sure to time myself on this. So with that said, I want to get to the expression problems and get to the word problems. So moving forward, we got, I'm gonna skip the working with negatives. I'm gonna skip that. I'm gonna post this into the group and actually make a video for this slide so that everybody gets it. I'm promising you that right now. I literally over-prepared for this. I've made way too many problems, and I always do that. So what I'm gonna do now, we're gonna go into the timed practice. So this is where you have your complete full options again. You can write it on paper or you can try mental math. It's up to you now. I wanna see who's gonna take the leap of faith and use mental math all the way through. So if you're ready, type "I'm ready" in all caps with exclamation points in terms of how excited you are in the chat box. So let's get it. If you're
What if
ready.
I'm not ready?
Ready.
Ready with 3 Y's. Ready. I want to hear a SpongeBob. I'm ready. I'll never grow up, man. I promise. Ready, ready, ready. Sounds good, everybody. So on the ASVAB, you get just about a minute for the arithmetic reasoning. You get 1 minute, 12 seconds. Mathematics knowledge, you get 57 seconds. I'm going to give you exactly 57 seconds. You can do it on paper or do it in your head. Let's see who's going to win. 3, 2, 1, go. Time practice. Number 1. 57 seconds.
Okay.
Now let's see who knows their order operations.
Is that an X or a times?
Times. Yeah, this is expressions. "57 seconds. We got this, guys. Three, 2, 1, time. What do we got? Hey, -20. The first 5 of us there. Really confident. You really roared in there. Okay.
Negative 20.
Got myself
Kathy,
lost.
Sam, Chantel, Deja, and Artavia. It just says iPhone. But Artavia. All right, let's see if we got it right. And everybody, remember, if it takes us a little too long, just go ahead and type into the chat box. Just be honest. Just be like, I ran out of time. Because I'm not grading you on this. You're not going to fail the test if you fail this question. It's no problem. I just want to see how confident we are about our ability to grow and learn. That's all I want to know, guys. So come on, let us know. Jaslyn, thank you. You ran out of time? Completely fine. Let's get to it here. So, what do we know about the order operations, guys? What do we always need to take care of first?
Parentheses.
Yeah, Pam does. Parentheses first. So, before you even write anything down, here's what I always do. Angelina, no worries, I got you. So, here's what we always do. I like to outline what I'm going to do, my steps. So, I'm going to say, okay, I want to do 4 minus 8 first. After that, what am I looking at? The 10 or the 20?
10.
The 10.
10.
So this will be my next step. And then what do I do next?
And then the 20.
And then the 20. So I just use little lines like that to show how I'm going to outline my steps. Because remember, you don't have all the time in the world. You cannot write line by line and literally go 10 times, okay, that's -4 plus 2. Again, guys, I can do my taxes by the time this thing is done. 10 times -4, negative. No, we're not doing this. We're not doing this. We're not doing that. No.
did it.
No. Even though I just did, I'm a hypocrite. I know. The goal is to not do this. The goal is to not do that. So let me break it down and show you how casually we can do this. I promise you. You just have to follow along here. Let me just make this smaller and put it off to the side.
Yeah, I forgot the negative part. Oh, God.
It's all good. So let me just go ahead and use red here. I'm just going to follow my lines. Everybody, what's 4 minus 8 going to be in your head?
4.
-4, because you can do 8
Negative
minus
4,
4. That's a difference of 4, but it's going to be negative because the 8's bigger. So again, if that bothers you, if that wasn't quite quick enough for you, mental math. No way to go around it. Mental math. Seriously. So this is -4. And then you got to keep that in your head because I planned to do what next with that -4?
And then you times it by 10.
Okay, let's times it by 10. What's -4 times 10, everybody?
-40.
Again, and in your head, that's -40 now. So we've completed step 2 that I outlined. Now I have -40 plus 20. What's -40 plus 20? So if I take 40 away, but add 20 back, I'll be where? Still negative because it didn't add enough.
Yeah.
But
20, -20. But how I did it is I just like switched the sign. So it's like if you have a negative, switch it. So it's going to be a subtraction. That's how I did it basically.
Exactly.
And then I
So
know
you
it's
do -40
20.
plus 20. You can do 40 minus 20 and then just make it
Mhm.
at the end. So shout yourself out. Did anybody here use mental math?
Yep.
All the way.
Yep.
You got it right, Octavia? All right. And
I
even,
did too.
even
I
if you
did.
halfway
I
mental
don't know
math
paper.
partially, still be proud of that because you are trying. You are trying. Seriously. That's why I'm proud of you guys because you guys are always willing to try. Let's get it done. A is the answer. Good stuff. Who's ready for the next one?
I am. I'm ready.
That sounds good. 57 seconds again. 3, 2, 1, go. 57 seconds. Again, everybody try your best. Try your best, guys. You got this.
Three.
3, 2, 1. What do we got? Again, even if you
Let's see.
guess, take a guess. If you need to, just shout yourself out and say you took a guess. If you ran out of time, say you ran out of time. Just be honest. I hate that some of us, if not right now, but like in other sessions that I run, that some people just wait until someone else gives the answer, then they give it. Guys, the test doesn't work like that. The test does not work like that. No one's going to be sitting there doing the same problems that you can cheat off of. You're doing it by yourself. Thanks, Angelina, for being honest. You guessed, that's fine. That's fine. We're
I
going to work on
did.
this. You guessed too, Octavia?
Yeah, I was like basically
Yes,
that
I
myself.
got
was like
confused.
confused. It's like D,
Let's go
but I
on.
was like, wait, I'm way off.
All right, so this is where you outline your steps. So if I'm looking at this, what's the first thing we should probably do?
In the parentheses.
Right, but is there
Parentheses.
anything to do in the parentheses?
No.
No. So what's the next thing to
No.
look at?
The multiplication.
Yeah.
All right.
multiplication.
So this is where I'm analyzing before I begin. This is what I always do before I do a problem. I just want to know that I'm dealing with what I know I'm dealing with. So I know I'm going to multiply this. Once I multiply those together, whatever the heck number that is, don't worry about the operation yet. But whatever number that's going to be, am I going to do that right away with something else, or do I have to do something else? What, Sam?
You have to multiply the other one too.
Exactly. We got to multiply the 5 and the 2 together. So in my head, I'm saying I'm doing 8 and negative 6 and 5 and 2. Then what I'm going to do with both of those answers?
Add 'em.
Add them together.
And then add them together. Notice how I'm using very simple lines to just keep myself in check. That's all I'm doing. Keeping myself in check. I'm doing this and that and then adding together. So now I'll do it in my head. 8 times negative 6 is what, everybody?
Negative 48.
Negative 48. And you will not know that absolutely without a doubt unless you practice your mental math. I keep advertising it. I swear to God, I'm gonna sound like a broken record, but somebody here is gonna be doing mental math, and that's all that matters to me. 5 times 2, very easy, that's 10. So now we have negative 48. If I take away 48 but give 10 back, I'm at what now?
Negative 38.
Done. Or you can say 48 minus 10, then make it negative again. Either way works out fine. Confidence level, is it going up or down with these problems so far? Your confidence going up or down? All the way up. Yeah, that's right. All right, cool. That's how it's supposed to be, guys. Up like 7-Up. Man, all right, sounds good, guys. Sounds good. And everybody else who isn't typing into the chat box regularly, just know that you can join in, you can type in, get involved. Because notice how the people that are involved right now, they're the ones that, even though they struggle at first, always end up getting it. So I just don't want you guys to sit there and feel like you can't participate if you don't know it. We're here because we don't know it. And I'm just welcoming you to really participate in this because it's going to grow. So here we go. Next one, 57 seconds as always. 3, 2, 1, go. Just outline those steps and then do it. That's how you build confidence.
Until 3. Oh, okay, I'm done.
3, 2, 1, answer.
B.
Yes.
Okay.
I was like doing the baby step first. So I was like, wait,
Oh.
do this first and then do that. I was
If
like,
you took
okay.
it too long,
And
go
I got-
ahead, write it out. If you ran out of time, write it out. Be honest, be honest. I know some of us have a little connection lag, so we'll see their answers coming in a second, and that's fine. But be honest about it. Did it take you too long to do it? Because I want you to keep pointing out to yourself if it does, because that's what you want to focus on. Time, being faster. Because if you know if you have more time, that's great. Just start working on speed now. But even if like you have 2 or 3 minutes and you still can't get it, that means it's a concept thing, and we need to revisit the actual skills and learn it from the ground up. But if right now your problem is just running out of time, guys, that's the best thing possible because you can take care of that by yourself. But if you don't know what's going on, you need a teacher. Does that make sense?
Yes.
So if you're running out of time, be proud of that because that means that, hey, I know I can get it. I know what the next step is, just working for speed. That should make you feel good. But if you're completely lost, that means, hey, maybe I need a little more TLC, a little more teaching here so we can get it done. So when I'm going through this, in my head, I'm saying, hey, look, I see multiplication, then subtraction, then addition. That's the order. Boom. locked in. 3 times 4, 12.
Oh yeah.
Check. Then subtract 10, 2.
Every
Check.
2. And
And I
then
add a -3, which is the same thing as subtracting 3, negative.
that'd be -1.
Check. That's my answer. I know I'm right because I did the operations right, and I double check myself at every step. Boom, -1's the answer. And that's it.
Yeah.
And that's it. So who got it done in less
Okay.
than 20 seconds? Anybody get it right in like less than 20 seconds, less than 30 seconds?
Oh no. It took me a little longer, but I got it right.
Right? So you took it down to the wire, but notice how in the first one you ran out of time.
Yeah.
Again, progress. That's what it looks like in real time. That's
I
number
messed
one.
up because I wanted to multiply the 10 with the 3 instead of just add, because I saw the plus, but then I was like, maybe I have to multiply anyways. And then none of the answers is what I got. And now I don't know. I was just thinking about it and I took too long.
Yeah.
That's what I.
Okay, so what happened at the 2? After the 2, what you do after the 2?
So yeah, what I did was when you look at this right here, adding a -3, really what that turns into, and Angelina, don't forget to remind me, I'm going to let you talk right after that because I know you had something to say. Adding a -3 is the same thing as subtracting 3. And the reason for that, just to make it very clear to us, let's say I'm adding that -3 again, right? Notice how there's a parentheses. Everybody, if we don't see a number in front of the parentheses, what number is always there?
1.
1.
A 1. And we know that inherently. Most of us know that, and that's great. And so what's going to happen is we need to distribute whatever's outside of the parentheses to everything inside. So what's a +1 times a -3?
-3.
-3.
Right. So this entire thing just turns into -3. That's the proof there. That's why it works. So whenever you see a plus negative number, it's the same thing as subtracting, because once you distribute, which not everybody does in terms of seeing it that way, because we don't have to, but if you see a plus negative number, it's the same thing as subtracting that number. Same thing as subtracting that number. I gotta get a new Apple Pencil. These things are expensive, man. Crap. It keeps like.
Do you like order your like Apple Pencil like from Amazon? You get some good deals from there.
Yeah, I probably could for sure.
Yeah.
I'll look into it. But that's the idea. That's the idea. Again, outlining your steps before you do it and then doing it. That's the 3 C's of problem solving, like I told you. The context, the content, and then the solution, the computing. Look at the content first. Here we go. Next one. 3, 2, 1, go. 57 seconds. Never mind. Actually, a minute and a half. A minute and a half. Decimals. Go. And you can write if you want to. You can write if you want to, or you can try to do it in your head. 1 minute, 30 seconds.
This.
Five, 4, 3, 2, 1. Answers.
I guess it's B. I just ran on time and I was a little lost, so I had to guess a
Be
bit.
honest. Yeah, give your answers. Say, I don't know. Say, ran out of time. Say what you got to say.
I don't
Let
know.
it all out. Let that frustration out. There we go.
I was like so lost because you guys -3.6 and then somebody you times 3 by 6, you give you 18. I was
Yeah.
like, wait, what do you do with 3.6?
Yeah.
Oh my god.
This was
So let me actually be very, very honest with y'all. This was a challenge problem simply because there were a couple of things going on. Obviously, you got a couple decimals. but I'm going to show you, I'm going to expose y'all to something that maybe we didn't know. Did anybody here multiply first?
Yeah.
Yeah, I did that.
Wrong.
I started most times.
Wrong. Guys, let me go ahead and show you something about PEMDAS. PEMDAS is the order of operations. So let me.
You could have did the division first.
There we go. All right, so PEMDAS is the order of operations. It's parentheses, exponent, and then it's multiplication division. Either one.
So either or.
Yeah,
Either one.
or.
And then it's subtraction and addition, whichever comes first. That's something that not a lot of us knew. And let me go ahead and explain why. Everybody pay attention to me for a quick moment, please. Can everybody see my face while I'm talking?
Yeah.
Mm-hmm.
Okay, cool, because it's just not showing up for me, so I was just making sure. So here's the idea. When it comes to multiplication and division, when we multiply a number, typically we're making it bigger, right?
Mm-hmm.
And when we divide a number, we're making it smaller. But the idea, though, is the same. Making something bigger and making something smaller is the same thing as just changing its size. And what I'm saying is multiplication and division are the same operation. One of them is just going in the bigger direction and one's going in the smaller direction. But they're the same operation in the same exact way that addition and subtraction are. So listen to this. If you're looking at a number line, think about a number line, get some PTSD really quick. Okay, cool. So if you're looking at a number line, if you add something on a number line, typically the number goes up. And if you subtract from the number line, the number typically goes left. It'll go to the right if you add, it'll go to the left if you subtract, right? What's the same thing? What's the commonality? The common thing is that you're just moving right or left. Again, you're moving either way. Adding means you're moving to the right. Subtracting means you're moving to the left. It's the same operation. You're just moving right or left, adding or subtracting. Multiplication and division, you're just changing the size, making it bigger or making it smaller. They are the same operations. So that's why it's grouped the way it is. And so you read it, whichever one comes first. First come, first serve. So what we actually should have done was this first. Then once we have whatever number that is, then we multiply with a 6. And then at the end, we add the 4. So I don't care if we know what the numbers are yet, but does everybody understand the process? Divide first, then multiply the result, then add that 9.4 at the end. Yes or no?
Mm-hmm.
Good. So that's 3 of us. Who else? That's all the 5 people here that are saying yes to. So that's what, 8 people now, 9 people.
Yes.
Good.
But you said it doesn't matter if you start with the multiplication or division, but now it does in this one.
Good question. Very good question. So here's the thing. With a fraction, it's a very different game. Because with a fraction, you can simplify from top to bottom first, or you can multiply across. A fraction is very, very different. And I'm going to explain that in another group tutoring session. But right now, just register it in your head. When it comes to order of operations, when it comes to looking at like this, it's all left to right. Notice how if you're like doing 8 times 10 over 2, notice how it's like if you're reading left to right, well, the 10 and the 2 are in the same place if you're reading it left to right. So that's why you can do either one first. But when it comes to like this, you're not reading it as, oh, this is, because here's 2 ways to read it. That way I can just make it make sense right now. This can mean 2 things. You can read this as negative 3.6 divided by 3 and then times 6, which is what it's supposed to look like. Some other people might think about it as negative 3.6 divided by 3 times 6. And then they end up doing the 3 times 6 first and then dividing, which is the wrong way to go about it. So reading left to right, you're completely doing the 3.6 dividing by 3, then times 6. Because from left to right, that's how it's going. And that's how it'll look like if you wrote it out. But with a fraction, it's, again, 10 divided by 2 at the same time. So you get to pick when it's that case. Does that make sense now, everybody? And even if it doesn't, again, I'll have a live lesson for this one. I'll make videos for it. My plan is to build up as many problems as possible and ideas as possible and videos for you guys to benefit from. So here we are, though. I'm going to say, hey, negative 3.6 divide 3. Everybody in your heads, what's that going to be?
Negative 1.2.
Yes, because negative
Negative
3
1.2,
divided by
yeah.
3, negative 1. 0.6 divided by 3, you can think about that as 6 divided by 3, which is 2, but there's a decimal, so you bring it back. So it's negative 1.2. So now let's think about the rest of the problem here, where we multiply by 6 and add 9.4. Notice how I'm not trying to save the world and do it all mental math right now. If it's a little more complicated, it's completely okay to ease it out a little bit by writing it out. Writing it out is meant to help you, not to be a crutch, if that makes sense. So then here, negative 1.2 times 6, negative 7.4. Because 1 times 6 is 6, 0.2 times 6 is 12, 1.2. Back to that. So 7.2. And then I see that negative 7.2 and 9.4 added together, I can just say 9.4 minus 7.2, which is 2.2. But it takes a little bit to build up to that. It really does. Did anybody get it right the first time around? That's okay. Do you believe in yourself in terms of being able to work up to this? Good. Good. I want you to believe in yourself. That's what it's all about. Because again, I'm not trying to save the world in one day. It's up to you. You have to work on that and practice little by little. All right, so here's what I want to do next. I'm not going to do this next one because obviously we have 12 minutes left and we have word problems to do that I really want to get to. So we're going to talk about these 3 C's here. And so before we begin, pay close attention. I'm just going to put the company logo. Here's the idea. In word problem, read the problem first. Ask yourself what's going on, not math-wise, Just say, hey, what's the story about and what is it that they want to do? Then make a little plan really quick in your head and then execute it. Don't freak out and just read the first 2 numbers that you see and just sing Hail Mary and add them. Don't do that. Seriously, plan it out, then do it. I'm going to explain more about what that means in a second. So we were supposed to have 4 operations here and then word problems. You see all that I had planned? It's crazy. You're going to get all this. Don't worry about it. So here we go. Word problems, 57 seconds. 3, 2, 1, go. And you can use your paper if you'd like to, or use mental math. Again, I'm not trying to crutch you. Do it the best way you know how, because this is live practice. Three, 2, 1, and 0. All right. All right.
Time.
Yeah, be honest. If you run out of time, if you have a solid answer, let's go ahead and take a look here. Man, I swear my hair would be a disaster right now if I didn't have this pick. All right, so here we go. So here's the idea with word problems. We need to extract the important information. Does it matter that this person's name is Blake?
No.
No. Just literally, you need to train yourself as we keep doing problems more and more and more to simply ignore the irrelevant information. So I'm reading this and I'm like, okay, someone burned that many calories on the run so far. Notice that it didn't even waste my breath. I didn't even read the number. The number doesn't matter. It's about what the number means. Here's what that means. So Blake burned this many calories so far. If his goal is to burn this many calories, how many more does he have to burn? What's the key phrase there? What's the phrase that you recognize the most in there?
How many more?
Ooh, you guys know it. Exactly. How many more? That phrase, how many more, almost every time means?
Subtract.
It means subtract. Subtract. Because think about it in real life. If it doesn't make sense in the problem, always think of a real life example. If I say, hey, I have $5 and I need to get to $10. How many more dollars do I need? Oh, subtract 10 minus 5 to see I need $5 more. So quick. That's a quick example. That's awesome. I can apply that here and say, hey, if I need to get to 625 and I have 245.6 so far, I just need to subtract. Notice how I made that plan in about 20 seconds, 25 seconds. That's the idea. The majority of your time in a problem, in a word problem especially, is not actually doing the problem. You need to make sure you're quick enough with the mental math and the actual on paper math to be just lightning. The majority of your time is spent planning out what needs to be done. Because think about it. If you broke that down and said, oh, I need to subtract, and I set this up, do you feel confident before you continue that you're going to get the right answer?
No.
No, not yet. Well, the thing is, over time, if you extract that information and say, oh, how many more definitely means subtract. It means how many more I need. So I'm going to subtract the total, what I need to get to what I have so far. And then I'm going to do it. Because what you're telling yourself is, I know what this means. I know that this means I'm trying to get to 625. I already have 245.6. So my answer will be how many more I need. And so you can feel super confident that no matter what number you get, that's the right answer. And that's how we're going to do it. We can do it on paper or we can do mental math. It's 3 digits. Do it on paper. So then 4, 10, boom. Can't do that. 14. 14 minus 5, everybody?
9.
9. Then the 1 minus 4, can't do that. What's 11 minus 4? Everybody quick. You're mouthing it, Kathy, but say it.
5.
Oh, you're muted, by the way, Kathy. You've been muted the whole time, I think. And then 5 minus 2. 3. And so boom, notice how this takes us like 10 seconds if we are quick with it, if we're awake. That's the fastest part. That's the easiest part. It's actually interpreting the word problem that's hard. And so that's why the answer is A, 379.4.
Oh man, I need a lot of practice.
Yeah, because the thing is, the ASVAB is not just about your ability to mindlessly do math. It is about reading the information and understanding what needs to be done with that information. Because in real life, that's exactly what happens. You have information in front of you that you need to make decisions with to get to the right solution in life.
The way I found, I just added like numbers, so 379.4 to 245.6, and then you end up getting around there.
Right, and so you guessed and checked. That's a valid strategy. But what if that 379.4 was answer choice D, not A? You would have been adding all 3 or all 4 of them, right?
Yeah.
Yeah. And I'm not going to knock you. You got the right answer. You deserve the applause. But will that always work? You got to rely on what will always work. Because if you literally add all 4 numbers, you just wasted a lot of time. Okay. Let's keep doing another one. I don't have anything like special announcements at all at the end of this. So we're going to do 2 more and we're done. Okay. So here we go. 57 seconds starting now. Remember, interpret the information. Just see what you can understand. Think about it realistically. Try to imagine the situation. Boring you, Angelina?
No, no.
I'm joking.
My bad.
No, I'm joking. I'm joking. I do that all the time. All right, 3, 2, 1. What do we got? And if we ran out of time, let me know.
B. Time.
Let me know. But did you know what you needed to do? Maybe you just ran out of time. If that's the case, and that's fine too. We have 1, 2, 3, 4, 5, 6 D's.
I got D. I'll take D.
Yeah, I'm lost.
Well, here's the answer. So when I'm reading this, again, somebody's refilling their pool. After they fill it with this many gallons, it's a third of the way full. How many gallons does the pool hold? So when I read that, I imagined, okay, we got a kiddie pool, we're filling it up, and they're saying that this many gallons is a third of it. Okay. And we want to know how many gallons the pool holds. Are we trying to find out a part of the pool, the whole pool? What are we trying to find out?
Third of the pool.
Yeah, the whole
Gallon?
One third.
Like how many gallon can hold within the pool?
Exactly. How many gallons can the whole thing hold? Here's where the important information is. 24 gallons is a third of the whole pool. So what they're saying is 1/3 is 24 gallons.
Oh, okay.
So what is the whole pool? Think about it. What is a whole again? What number is a whole?
1?
Yes,
One.
absolutely. 1 is whole. But if you're thinking about a
Okay.
fraction though, 1 out of 3, what would be the whole thing? What out of 3?
3?
Yes. Yes. 3 out of 3 is the whole pool. So think about it like this, everybody. If I have 24 gallons as 1/3, how do I go from 1/3 to 3/3? Can I multiply something? Can I add something together? Like, how do I go from 1/3 to 3/3?
Multiply?
Yes. Jania, exactly. You can multiply. So here's one way to think about it. You can say, hey, if I multiply that by 3, I get to 3 out of 3. I get the whole thing. And I can say 24 times 3, and I can do it that way. Because 24 times 3 with mental math, I think this is probably the easiest thing you'll do now today. Notice how I over-prepared you. Now you can look back at this and say, oh, 20 times 3, 4 times 3, bring it together. What is it?
72.
Ooh, Jasmine, you're getting faster. Look at that. I just tested you right there. Boom, 72. That is one way of going about it. Another way of going about it is, let me grab green here. If 1/3 is 24 gallons, what would happen if I did 1/3 plus 1/3 plus 1/3? Would I get 3/3? I would.
Yeah.
I would definitely get the whole thing, right?
Mhm.
So if 24 gallons is 1/3, I'm adding 24, 24, and 24 together.
Which give you again 72.
Exactly, because 20, 20, and 20 is 60. 4, 4, and 4 is 12. 72. Either one of those techniques will work, but notice how mental math is a tool. It is not your savior. It is a tool to get this done faster. Your paper and pencil is a tool to get this done faster. Do you see what I'm saying here, guys? Instead of physically writing everything out and spending more time than you need to, I'm telling you, I'm showing you that you can think faster than you can pick up a pencil, put it on the paper, and write everything out. You are faster than that. And I want to expose you to that idea.